So once again, as you know, before getting into the joint time frequency analysis, we want to get into what is a time frequency analysis. And time frequency analysis, as you know, this biological signals which are actually constantly non-stationary signals. So non-stationary அப்படின்னு சொன்னோம்னா, that signal which doesn't have a proper stationary or proper variation in with respect to the time. But we know the ECT signal should be in this range, this form, this amplitude, this much time differences will be there. Even though comparing to that, we do not come up with that exactly because if there is some abnormality in our heart muscles or due to some external stress or some pressure or maybe some any kind of stress things, our heart muscles, everything may vary. So due to that, the electrical activity of that heart varies. So it is, we generally call all our biological signals are non-stationary signals. So when we are analyzing those signals, that is in case of time frequency analysis. So we are analyzing in both the cases of time as well as in frequency range. So it gives the information in both the cases as time as well as in frequency. So this actually, yes, yes. Did anybody said anything? Am I audible?
Yes, ma'am.
So is it visible your presentation now? So by analyzing in the case of time and frequency, we can understand the transient events in the signals. Here, for example, you can see in this picture, this is this signal which actually depicts in terms of time, right? But here what we are saying is in terms of frequencies, depending upon the frequency range, the signal is categorized. This signal is your like a raw EEG signal, that is electroencephalogram signals. So we are categorizing those signals according to the type of frequency. As you all know, the frequency of EEG signal is from 0.05 to 30 hertz, right? So we'll be categorizing from 0.05 to 4 hertz is your alpha, gamma frequencies. So like that, you'll be categorizing 0.5 to 4, 4 to 8, 8 to 13, 13 to 30 is your alpha, beta and theta and gamma signals. So like that, you will be like going with the frequency range, but in overview with the time period, like from the time period from zero point 0.5 milliseconds to 1 second, it is this frequency. So depending upon the time and frequency analysis, you can depict what actually it is telling or what is the event which is actually happening in our brain, right? So that is what here they have given up with the solution. This is how you'll be analyzing through your time frequency. And what is the purpose or what is the need for having this time frequency analysis in biomedical signal processing? It actually lacks our temporal localization, that is the classical Fourier transform which lacks the temporal localization. அதாவது இதோட மீனிங் என்னன்னு பாத்தீங்கன்னா, ஒரு ஃபோரியர் டிரான்ஸ்ஃபார்ம் நம்ம யூஸ் பண்ணும்போது பர்டிகுலரா இந்த டைம்ல தான் இருக்கு, இந்த ஃப்ரீக்குவன்சில வந்துட்டு இருக்கு அப்படிங்கிற ஈவெண்ட்டை நம்ம வந்து எடுக்க முடியாது. ஃபார் எக்ஸாம்பிள், இஃப் அ பர்சன் இஸ் கெட்டிங் அ சீஷர், அதாவது சீஷர் ஆக்டிவிட்டி நடக்குது அப்படிங்கும்போது அந்த சீஷர் ஆக்டிவிட்டியோட ப்ராப்பர் டைம் டியூரேஷன் எவ்வளவு இருந்துச்சு, அந்த சீஷர் ஆக்டிவிட்டி நடக்கும்போது வாட் இஸ் த ஃப்ரீக்வன்சி அப்படிங்கிற எக்ஸாக்ட் வேல்யூவை வந்து we cannot attain it. So that is the lack in case of if we are using our classical Fourier transform. As you know, Fourier transform is one of the best method to analyze our signals. But even though we cannot get the temporal localization of a particular event which is happening in the body. So that is one of the requirement where we go for this TFA, that is time frequency analysis. As you know, this non-stationary, all the physiological signals which requires the localized analysis. அதாவது அந்த பர்டிகுலர் டைம்ல என்ன நடந்துட்டு இருக்கு, இந்த டைம் வந்துச்சுன்னா, இந்த frequency வந்துச்சுன்னா, இந்த டியூரேஷனுக்கு ஆர் இந்த விண்டோ பீரியட்க்கு what is the thing which is happening in our body அப்படிங்கிற analysis we need to know. That is the basic purpose of going for this TFA signals. Okay. So TFA signal என்ன பண்ணுதுன்னா, உங்களுக்கு which captures frequency which changes over the time. டைம் டியூரேஷன்ல ஒரு சிக்னல் போயிட்டு இருக்க அந்த frequency வேரியேஷன் வச்சு it gives the depiction what is actually happening. Right? Is it clear? Why we are actually going for this TFA-ங்கிறது? That is time frequency analysis. Is it clear? Yes. So, coming to the limitations of your Fourier as well as short time Fourier transform, both Fourier transform and short time Fourier transform. Fourier transform, which gives very good frequency resolution, we know that, right? But it lacks in the time resolution. So it has a very poor time resolution. So that we generally don't go for this Fourier transform. Short time Fourier transform என்ன பண்ணுதுன்னா, fixed window limits கொடுத்து அதுக்கான proper frequency கிடைக்கும். அதாவது ஒரு particular time periodல, for example 0.5 milliseconds to 1 maybe 5 milliseconds வரைக்கும் இருக்கிற time windowக்குள்ளார இருக்கிற analysis மட்டும் எனக்கு பண்ணணும்னா it gives a proper solution, but only for that fixed time window. If for a continuous monitoring, if it is going for a particular long duration of analysis, or if I want to analyze the signals in ஒரு time window period of for 1 hour or an entire sleep period அப்படின்னு போகும்போது this does not give a proper resolution. So that is where the limitations of these Fourier and STFT lies, and that is where your signals also gives a proper solution. Is that clear? Why actually we are going for this? Yes. And here what we are introducing our wavelet transform concept. So wavelet transform எதுக்காக இங்க why actually we are introducing wavelet transform in the case of the signals and systems is used to analyze the scaled as well as the shifted versions of our mother wavelet. So பாத்தீங்கன்னா இப்ப நமக்கு தெரியும் ஒரு ECG signal வந்து appear ஆகும். Once we start our signal, the ECG signal appears. ECG signal ஓட basic frequency range என்னப்பா? Give it in the chat. What is the basic frequency range of your ECG signal? Give the solution in the chat. Fast. Yes. ECG signal frequency range. Give it in the chat. Chat open பண்ண தெரியலையா? So I'll call random names, okay? Harini K. Harini. I think I have to take attendance right now. Harini. Kriba.